Okay. So just one feedback I need, guys, from you is, are you able to hear me properly? You can type in the feedback if that's possible.
Yeah.
All right. Thank you so much. So let's get started with big data ingestion with Kafka. So I'm Chinmay Kolharkar. I'm a committer in Apache Apex, and I have been working with Data Torrent. Basically, we are the company where big data technologies are undertaken, and Apex is a streaming platform that I work with. So let's go to the agenda slide. Let's see what all we are going to cover today. So first of all, we'll see what a data ingestion means. We'll see what are the different use cases which are there, and particular use case that I want to see is Kafka to HDFS. And that's one of the simplest use case, but the reason I chose that use case is because then I can actually demo to you how this particular ingestion can be done with Apex in picture. Now, while we go about doing that, I just want to give a quick brief about what a Kafka technology is, and that's a very short brief. We'll be focusing on Apex here, and later on we'll go through different generic development steps for developing an Apex application, and then I'll finally take you to the command prompt and show you how it is done. Okay. So, what is data ingestion? Now, data ingestion means that we read the data from a certain source. So the data is being read in from a certain source, and the data is being stored into a certain accessible location. So for example, you have two different HBase clusters. The data is being read from one HBase cluster that is reading in the data. My current existing HBase cluster will basically have the processing unit, whatever are present, and I'm going to process the data and store it there. Okay. So basically what this means is it indicates a beginning of the data ingestion pipeline. Okay, so basically it's right path. From this point onwards, there is some processing which is going to happen further on this on the data in question, and that is what becomes a read path. Okay. So the data ingestion that we are going to talk about here is the beginning of the pipeline, that is taking a data from some source and writing it to a destination. I know that there are a number of different definitions people have for data ingestion, and they are all correct, by the way. What I want to showcase here is a technology using which a data ingestion can be done, and that is Apex. So what I've done is a use case to choose. Basically, this is the use case that I've chosen to show how Apex can be used for the data ingestion purpose, and that is from a Kafka cluster to an HDFS cluster. Now, I'm going to write an application in front of you after a while. I'm going to read the data from the Kafka messaging queue and write that data to an HDFS output system. So it's very simple, very simple application there. So we have only two components, where the Kafka component and the HDFS component there. Now, a couple of examples I just want to go through for where this particular type of application is used is, first of all, is in log aggregation. So you have logs which are present in various different sources. So if you know about SIEM systems, so there are logs which are present in all the different computers in the enterprise network. So that those might be sys logs, those might be some other Windows-based logging system, where all the different logs are present, where event is being recorded. Now all those logs needs to be aggregated, put together, and they are being streamed for a certain processing. So that's a log aggregation example, where we can take the logs from various different sources and put it to a centralized location, maybe that is HDFS, and later on use it for the further processing. The other example is real-time sensor data. So this is more related to IoT-based systems, where the data is coming from various different IoT systems. They might be sensor, they might be user data, and so on. But the data is being again retrieved from various different sources. It is first processed as a stream, and then the results are dumped into HDFS. So you can see that there's a difference in the data ingestion that I've used here. So in the first example, I have taken the data into a centralized place and then I intend to process it. In the second example, I'm taking the data into a stream, processing it, and then dumping the results into HDFS. So as I said before, data ingestion, one would have a different understanding of it. Okay. So any questions till this point?
No.
All right. So there's one of the important technologies that is involved here is KAFKA. So KAFKA is basically a distributed messaging system where the data that is flowing is what is called as a message. And distributed means that various different people can subscribe to it, various different people can publish to it. We'll see about what is the meaning of these two words. It supports for very fast reads and writes, and that's what KAFKA is very popular for. Along with the large number of clients that it can handle, KAFKA has shown some tremendous performance related to read and writes. Along with these features, it also supports scalability, fault tolerance, and partitionability. So scalable means if the number of resources are more, the topics further, so that processing can happen at that particular rate. And fault tolerant is something which is related to the last point that I mentioned, that is persistent. So the messages of the system are written down to the persistent disk, so that in case of fault tolerance, those messages can be retrieved and replayed if required. Continuing on with the brief about KAFKA, so these are a couple of terminologies which are there. So a couple of terminologies which are there related to KAFKA is, first of all, it's a topic. So in KAFKA, the terminology topic means that any data that is flowing on a stream is associated with a certain topic. Okay. So there is no data which is out of bound of a certain topic. It's everything is associated or part of a single topic. Second thing is a producer. Now, as you can see there in the diagram at above, you can see that there are n number of producers which are there. Those might be front-end system, those might be services, those might be servers, and so on, where the data is being produced and put it into a KAFKA cluster. This particular intermediate entity called as KAFKA is called as broker. So this is the main entity which is going to redirect the data from producers to the consumers. And lastly, we have consumers which are going to talk to the brokers and consume the data that is produced by the producer. So you can see that the variety of examples of consumers which are there, like Hadoop clusters, they might be security systems, there might be real-time monitoring, data warehouses, and so on. So that's how extensible the KAFKA is. So any questions on KAFKA?
Yeah, one question is there. Is it like MQTT, RabbitMQ, JMS? I mean,
okay.
Is it similar, at least in terms of the technology or the usage point of view?
Yes. So from a functionality or usage point of view, they fall under the same bucket. But I am sure that both these technologies or individual technologies have their own pros and cons.
Yeah.
And it's a matter of evaluating individual technologies and choosing one of those. KAFKA, the reason why I have chosen KAFKA is here. KAFKA is that way closer to Hadoop. It's been more commonly used along with Hadoop, so that's why I've used it.
So there's one more question which says, in case a message or table fails, may I know what is the remedy to retrieve the message? So, so this is by Krishna Swami. So my question to this addition, there are two sides. So one entity is sending data to KAFKA and other entity is reading it. So when I'm a client who is pushing data to KAFKA, it's the client's responsibility to make sure the tuple is sent. Like KAFKA side, it won't be retried if something is not in. So if the client who is pushing the data to KAFKA needs to take care, retry or whatever, make sure that the tuple is sent. Right?
Okay. So if I understand, you are talking from a producer's point of view,
yes,
right?
Yes.
Okay. So There are two ways in which usually the data is being produced to the Kafka broker by the producer. So one of the way is when the client is actually generating data for the Kafka cluster, it can ask the Kafka cluster to give me an acknowledgement for it. Okay. When the acknowledgement is received, that means the data is persisted. Okay. The other way is that the producer might just go blindly and say that you just consume the data at whatever rate you can, without sending me the acknowledgement. In that case, Kafka cluster makes sure that as long as there is no structural issue or functional issues happening inside the cluster, it persists the data. But of course, there are situations where things might fail, and in that scenario, the producer needs to take care of the fact that what data has been sent. And if something is not being recorded with the Kafka cluster, it needs to be sent.
Okay. So few more questions. Is Kafka similar to TIBCO?
I'm not sure about TIBCO, to be honest. I'm really sorry.
Okay. So one more suggestion is the presenter to repeat the question before answering. So I think it's quite clear for you.
Okay. So the question was about is Kafka similar to TIBCO? So I mean, my answer to that is have not worked on TIBCO as such. So but I would like to take that question offline and let me see what I can dig into from web, and I will reply to this.
Okay. So other question is, can consumer be NoSQL or SQL database?
So so the question is, can consumer be NoSQL or SQL database? Now, by the terminology of consumer, what we mean here is consumer is somebody who is going to consume the data from the Kafka cluster, and it has to use a Kafka client to do that. Technically speaking, any software that uses this Kafka library or Kafka client can become a consumer. So if there is any NoSQL or SQL databases which can leverage this particular library and read data from it, yes, it does.
Okay, so last one question I will take. If I broadcast a message to at least 500 people, how will I know that the message has reached to all 500 people?
So the question is that if you broadcast the message to 500 people, how would you know that it has reached to 500 people? Now this particular technology is Kafka technology, I mean to say, is not really worrying about whether it has reached the other end or not. Right. So this is a publisher subscriber mechanism. Okay. So what that means is producers are going to publish the messages to the broker, and there has to be the other end which is responsible for reading it from it. Broker is a layer which isolates the producer and consumer layer. So as such, with Kafka technology, to my best understanding, there is no connection between producer and consumer.
So some of the questions I will aggregate and will ask at the end, which are not really relevant to this understanding right away. Okay. So bear with me in case your question is not answered right away. I will try to keep it coherent with this talk, and other questions we can take it towards the end of the session.
Sure. Thanks, Sandeep.
Just one more.
Okay.
Yeah, Durga, you have any question?
Yeah. Am I audible?
Yeah.
Yeah, you're.
Yeah. Which steps will be carried out in Kafka? Is it like a HDFS map and reduce functionalities carried out by this Kafka system, or is something similar to that?
So I'm sorry, I couldn't get your name.
Durga.
Durga. Durga, basically Kafka is not related to processing of the data. So Kafka is not really going to process the data as such for you. It's not going to run any MapReduce job or streaming application inside that. What it is going to do is it's going to provide you a gate which allows the data to flow from one end to other end. Okay, so it's like a pipeline. It's like a pipeline. where on one end there are multiple inputs to it, and on the other end there are multiple outputs to it. And the functionality in between is going to make sure about all these aspects, distributed messaging and so on. Okay.
Yeah.
Fine. So now that we have covered the Kafka technology here, let's deep dive into Apex now, and let's see how we can leverage the Apex technology to do a data ingestion with Kafka to HDFS. Okay. So just briefly, I want to go through the steps that that are required for development, and they are pretty simple and very trivial as well. So the first one is Apex publishes Maven archetype. So one has to use the Maven, one has to create a Maven project using this particular Maven archetype. Then there are a couple of dependencies that one might need to add for Maven project to work properly. So for example, in an ingestion application, we'll need to add a dependency for Kafka. We'll need to add a dependency for something called as Malhar library. I'll come to that in a minute. The third one is then finally we have to add the different Apex operators which are there to the DAG. Then later on connect those operators in the stream as a part of that DAG. Now the operators that we have added would have some properties for it to function at the runtime. So that's where we use something called as properties.xml to set those properties. And the last step is we finally compile and run it. Okay. So what do you guys say? Shall we go and do some coding?
Yes.
Any questions till that point? Okay.
No, I'm replying to some of the other miscellaneous questions offline. Yeah.
All right, cool. Okay, so, let me know when you can see my.
Yeah, it's just a bit lagged.
Okay.
So
yeah. Sure. So I'll go a little slow here. Okay. Can you see my Ubuntu?
Yep.
Okay. So as we said, the first step that we have to create is we have to create a Maven project using Maven archetype. So just for the sake of this particular demo, actually let's take a step back and let me show you what all Hadoop content I have here. So I have a Hadoop running. I have a Kafka cluster also running in my local box. So just bear with me if it is a little slower because everything is running in a single machine. So you can see that there are two folders here: aggregation module and a data torrent folder. Okay. I also want to show that what are the list of Kafka topics which are there, and I'm just going to copy paste this particular command to show the list of topics, and you can see, as you can see, there is no topic existing as of now. Okay. So as our Kafka is really in a question, so let's create a topic in this particular Kafka cluster. Okay. So you can see that this is a command for Kafka creation of Kafka topic. So we have used create switch, and we want to create a topic with the name of meetup. Okay. So the topic is created. Let's see whether we are able to see that topic again. Okay. So now you can see that there's a meetup topic which has got created. Now that we have all the setup being ready, let's go back and create a Maven project that we talked about. So this is a Maven command that is there, but just for sake of your own understanding, let me show you where exactly it is. So I have checked out Apache Apex source code as for the master branch into my local machine. So this particular directory structure is for the Apex. So if you want to see the command how you can create a Maven archetype, a project using Maven archetype, you can just go to this particular README file and you can see that this command is here. Okay. So couple of things that you would want to change in this is the name of the project is here, then the Java package that you want to create is this is here, and then you might want to change the group ID as well. Okay, up to you. So you can see this, you can take this particular command and this will create a Apex Maven project for you. But for the sake of convenience, what I'm having is I'm having a command with me already being pre-created. So let me run this command for you. So when I run this command, it's going to ask me, it's basically going to show me that, you know, various different properties that are being used to create a Maven project. So this is my group ID, then my artifact ID is going to be ingestion, package is com.meetup.ingestion, and finally it asks me whether I want to proceed with this particular setting. Okay, so let's create the project. Okay, so you can see that the project has got successfully created, and at this point of time, let me just quickly scroll up. So at this point of time, you will see an ingestion folder being created here. Okay, now I just want to go inside this folder and show you what exactly are the content in this. Okay, so there are a couple of files here. This is a POM file which is used to package, basically used to compile the code, and this is a main source folder which is there. There are other couple of folders, a couple of files which are present there, but you know, just for the sake of convenience, let's go to an ID and let's see how does that look. Okay. So do you guys see, is this font good for you?
Yeah, looks okay. Yeah, fair enough.
All right. So what I've done is the meetup folder that I showed you, I had imported that particular folder into this. So IntelliJ IDEA has been convenient enough for me to add that particular project automatically. All I'm going to do here is just add that as a Maven project. Okay. So, all right, let's see what are the content into this particular. Sorry, just hang on. This particular project. Okay. So first file is the pom.xml, and before I can show you that, I want to do one thing where I want to. Okay. So the pom.xml file contains the group ID that you will be pasted there in the command, the version of the particular project, the artifact. This is the name of the project. You can change this, and there are a couple of build related parameters which are part of it. And finally, you could as well see some of the dependencies which are being added to the project. Let me just scroll down. All right. So you can see that there are a couple of dependencies being added here. Okay. Now, going inside the SRC project, there are a couple of different folders which are there. Assemble folder is the one which is going to let you. It's basically going to assist the pom.xml to create an application package for Apex application launching. The main is the folder where your actual code resides. As you know, the test folder is where your test code resides, and this is one important folder that I want to show you guys is the resources folder. So this is the folder where your application properties are going to be present. Okay, so these are the properties which are going to be used for the runtime configuration. Okay. So, and lastly, this is of course this is the most important one where you have the class files which actually are used to launch an application. So as you can see, there are a couple of files already being created here by the Maven archetype. What we're going to do here is we are not going to use either of them actually. So let's delete this random number generator. Okay, something happened. Okay, and yeah, okay. So the dependency was there, and let's just clean up this populate tag method. We will also remove this, but empty this particular file because we want to do something totally different here. Okay. Now, before we start, as I said, the second step that we went through was to add the dependencies that we need to add to the project. So what we will do is, okay, let me just come out of the presentation mode here. Okay. So what we'll do is we'll add a couple of dependencies into this, and let me just add it quickly, and I'll walk you through what exactly I did there. So when I go back to my pom.xml, so this is the place where I usually add my dependencies. All right, so I just add these as the dependencies. Now you can see that there are two dependencies that I've added. One is a library called as Malhar contrib. So this is again part of Apache Apex. It's an open source library which is there. It contains a large number of operators which are used to perform different operations, so which contains input, output, and some processing units as well. And we also have added a Kafka as a dependency to our project because we want to have a Kafka to HDFS application there, right? So with this in mind, let's do one thing. So let's go back to our application.java file. Actually, yeah. So let's go back to our application.java file and let's try to add some operators to this particular application.
Yeah.
Okay. So the way we add these operators is a command called as dag.addOperator. So you can give any name to this particular operator. Let us give Kafka, and we are going to add an operator called as Kafka single port string input operator. Okay. So this is an operator that is coming from the Malhar contrib that we just recently added. Okay. So with this being added, we have established a connection of this particular application with the Kafka cluster. So the second end that we need to add is an HDFS output. So for that purpose, what we need to do is we need to create a class, and we don't need to do this really, but I just want to show how extensible this thing is. So what I'm going to do is I'm going to create a class called as HDFS out, and there is an abstract operator called as abstract file output operator. Okay, let me assign a type called a string to this. So I'm going to extend this particular operator, and I'm going to use this particular class to become an operator for our application. Okay. So the first method that I need to extend is the file name. So what this means is what is the file name in which my data that is coming from Kafka is going to be returned. So let me call this name of the file called as meetup. Okay. And lastly, there is a method called as get bytes from tuple. So essentially this particular operator is going to receive a data in a string format. Now to write it down to an HDFS file, it needs the data in a byte array. Now though it might look like very simple operation, but this is the place where I can control my string that I'm receiving, process it, maybe do a little bit of conversion or changes, and then convert and return back to byte array. So just to illustrate that, I'm going to do one thing. I'm going to append a new line character to the string that I receive, convert that to a byte array and return it. Okay. Now that's all I need to do to have an HDFS output operator. Okay. And finally, the last stage, as we did for Kafka, we also do the same thing for the HDFS output operator. We do dag.addOperator to HDFS. We give the name of the operator as HDFS, and this time we use the operator from our own particular project. So that is HDFS out. So what we saw here is one of the operator we have used from the Malhar contrib, and another operator that we wrote of our own, and now that we are using in an application. Okay. So now that we have added the two operators, let's connect these two operators together. So the API for that is called as add stream. So let's give the name of that API to as ingestion, ingest maybe. So the way I connect is first I give an output port of the first operator, that is Kafka.output port, and then I give input port of the next operator, that is HDFS.input port. Okay. Now you can see that in my HDFS out, none of this is present. But if you go inside this abstract file output operator, there's a bunch of things that it has done to make sure that the fault tolerance and scalability is maintained. Okay. And in this particular file itself, there's a public variable for the input port that I have access. Okay. Now, technically speaking, that's all I need to do to write an application. But there's one important missing element in this. Okay, that is, how do I configure these two operators that I've added? Okay, and that's when these properties.xml file comes into play. Okay, so as we saw, we have two operators in question. So first operator, let's configure the first operator. Actually, I do have the XML file content with me already. So let me just copy paste it and let me walk you through the content. Okay. So the first operator that I've added was the Kafka operator, right? So you can see the name of the Kafka, I have given it as Kafka here. So the way I configure the first property that I want to set on this Kafka operator is what topic I want to read the data from. Okay. So the name of the property in that particular Kafka operator is called as topic. Okay. And the name of the operator is Kafka. So considering that in mind, the name of my property becomes dt.operator.kafka.topic, and the value to that becomes meetup. The next property that I want to configure for Kafka is a zookeeper. Now, zookeeper is basically a quorum which manages a particular quorum of brokers for the Kafka. That's a required service for Kafka. So I have a zookeeper running on my local machine at 2181 port. So that's again, I'm setting the zookeeper property to the Kafka operator this way. Okay. And lastly, I want to configure my HDFS output operator. So the name of the operator again is HDFS. So I've given the property name as dt.operator.hdfs.filepath. So filepath is a variable that is present in my HDFS output operator, which is getting configured with this particular value. Okay. So what this means is whatever data is going to come from Kafka to HDFS is going to be written down to this particular path in HDFS. Okay. And we'll see that when we actually run it. But let me just quickly show before that I don't have anything there in it. So okay, you can see that I don't have a folder called as meetup here. Okay. All right. So now that we have done this, I'm about to launch an application. But before that, I want to take a logical break and ask if there are any questions.
So one question is, in what terms does Kafka need zookeeper? Repeat the question.
Okay. So the question is, in what terms, right? The Kafka needs zookeeper. So the functionality of zookeeper is it's basically an election agent. So you have n number of let's say you have n number of people who are standing for votes, and who is going to elect them is what zookeeper does. Now you have brokers in Kafka, right? So as I said, it's a distributed cluster. There are n number of brokers which are there, but one of them has to be a master, and other ones needs to follow them or be in line with them. Okay. Now, having said that, who chooses the master is a big question. At the same time, to a client, how would a client know which is the broker that is latest active or being updated at all the data that is there in the cluster? That is what is the job of zookeeper. Okay, did I answer the question?
Is there any way to add operators?
For Apex, we don't have a GUI, but there is a corresponding there's a platform called as Data.Ingestion which uses Apex, and that has a GUI using which you can add the operators on the fly.
Great. Thanks.
Any other questions?
No.
All right. Sandeep, I leave it to you to answer some questions. Thanks.
There is one.
Okay.
May I know the type of grouping? I'm not sure. Okay. Can I use Kafka new consumer? It doesn't use zookeeper.
I'm honestly not sure about that. So maybe best to take this question offline. We'll pose this answer to this question on Beta website.
Just a simple other one is how to group messages. I would say he's asking about the topics and partitions.
Okay, so so the question is how to group the messages.
Yeah.
So what I understand is how to assign them to a topic and to the various different partitions. Now, essentially, the client library provided by KAFKA is pretty open. So what that means is it has the KAFKA has given control, complete control to the producer and consumer in what topic the data is supposed to go, and that too in what partitions for that matter. Okay. KAFKA do have capability to load balance it across given fixed configuration, configurable number of partitions, but there are always use cases where people have chosen to write it down to a certain partition instead of letting KAFKA decide it. So it's completely user specific.
Yeah. Good.
All right. So just a quick recap that we saw. Sorry. So the quick recap that we saw was we created a Maven project. Okay. We added the Maven dependencies for Mallar contrib and Mallar and for KAFKA. We added the operators to the DAG. We connected those operators with the stream, and finally we set the properties of this operator in the property.xml. Now the last step is left, that is compile and run. So let's go and do that. And there's my terminal. Okay, so the way to do that is basically compiling a Maven project. Now this is a standard way that I use to compile a project, but I'm sure there are Maven experts who can tell you better way than this. All right, so this is going to build our application that we just wrote. So just let's give this few seconds. We should quickly get over. All right, so that's complete and the build is successful now. So before we proceed towards using this particular build that we just created, let us see what actually got created. Okay. Now previously we had seen a tree command that the target folder was not there. So let's see what is there as a part of this target folder. So you can see that there is a jar file which has got created. This jar file is going to contain the classes of the Java files that we have written in this particular project. And finally, another important file is called as APA file. So this is the name of the archetype, and this is the version of that archetype that you have given. So APA file is going to be created like this. So APA file means application package file. Now this file is going to contain everything that we have written in this project, along with the dependencies which are packed as a fat jar. So all that is required to run an Apex streaming application is part of this APA file. So all that is left to be done is a launching platform, and we'll see that in a minute. Sandeep, do we have any questions? All right. So we have an APA file created here, and we need to launch that. So let's see two of the launching platforms that are there in question. So the first one is provided with Apex. So as I told you that this is my Apex master that I've cloned from GitHub. So to go to a CLI for Apex to launch an application, so this is the path for it. So engine src main script, and then there's a script called as DTCLI. Okay. So when you launch this particular command, you see a console called as DT greater than in this particular CLI. And the command to launch a particular Apex application looks like this: launch and then path to APA file. So this is how the command actually looks like, and that's all that one needs to do to launch an application. But let me, before we go on to that, let me show another console that is provided as an open source or community, as a part of community edition of Data.RTS. So I have a platform I have a data torrent RTS community that is running with me. Okay, so this is another place where one can see what all different data torrent or streaming applications which are running, and we'll see how do they look and so on. So let's go ahead and launch the file that we created. Let me take the path from here. So this is my path, and I'm going to give a path to my API file. Okay, that's all I need to launch an Apex application. Okay, so you can see that the application is launched, and just to quickly check, I'm going to run a command called as list apps. You can see that I'm still actually in the DTCLI Apex console itself. You can see that this is the name of my application which is running. So my first app is essentially coming from the application.java file and from here. So my first app. If you change this, the name of the application changes. Okay, you can see that the state of this application is a running application. Now, as we know, this particular application is essentially a Yarn native application. So we can as well see that in the Yarn tracker there. Okay, but let's do one thing. So let's try to list all the operators which are there. So the command for that looks like list operators. That's all. Okay. Now there are two operators which are there that we added. The first one is the KAFKA operator. You can see the name of the operator is also preserved here. There's a class name which is being provided. There will be the second operator. Yeah, so second operator is the HDFS operator. The class name of that is HDFS out, and so on. So these are like some of the action items, some of the text that one should see, whether the status is active, and the status is active for this one as well, and so on. Okay, and these are the only two operators which are there. Okay, now let's go to the data torrent RTS community edition UI. You can see that now my first application is shown in running state here as well. Now when I click on this particular UI, I see a little better. Of course, that's a text editor that's been shown as a text. This is a UI, so it's going to be definitely a difference. But you can see that the two operators that we added, that is KAFKA and HDFS, are being shown here, and the stream that it is connecting with is ingest. Okay. Moreover, it also shows that how many number of tuples are being processed by each of these operators. Okay, so this is HDFS and KAFKA operator, and this is the total processed tuples which are there. Okay. Now currently nothing is there because my KAFKA channel is really empty. So to fill something into the KAFKA channel, let me use a KAFKA console producer to put some data into it. Okay. So I have a file called as syslog. So I just captured some time back. I just picked the syslog file in my local machine, and I've just copied it to my current working directory. So you can see that there are 9864 number of lines which are there as a part of it. Okay. So what we'll do is we'll take this particular file and populate that into my Kafka topic. Okay. So the command for that is Kafka console producer. I'm just giving a brokers list, and finally the topic in which I want to populate. Okay, and I'm doing a cat here. And pipe here, what that means is a new line character will be used to terminate a new message. Okay, so topic is not valid. Whatever. Okay. All right. So you can see that there are some data that has been received in these operators, and the proof of that is the total number of emitted records by Kafka and the total number of received records by the HDFS output operator. Okay, so you can see that this number matches with what we saw previously, so 9864. Okay, and So this is the number that's. Now the most important thing is, well, that's fine. All of this is working. How do I know whether the data is actually gone into Hadoop? So let's check that. Previously, we didn't see any meetup folder here. Okay. Now we are seeing a meetup folder here. Okay. So let's see a content of this. Now there's something which will be appended to this. This is just to make sure that the files are being rolled over efficiently, so that there's not too much load on HDFS that is coming up. But eventually this will go off. Okay, as more and more data gets written to this. So let's do one thing. Let's take this particular file and just do a cat on this, and I'm going to do a word count, line count on this particular file, because if I just cat it, it will be too much. So let's do a line count on this. Okay. And you can see that I received the same number of lines as I've sent it to the Kafka. Okay. Now that basically shows that all the data that is being received into the Kafka is been put into an HDFS file system. So that's all I have on the demo perspective. But I just want to summarize quickly on what we went through. So it's just 6 steps that we went through to write an Apex application, and we practically wrote a data ingestion pipeline. Okay, so that's how easy it is to do a streaming application development using Apex. We used a Kafka input operator, which is actually a Malhar component, and that shows that the reusability of Malhar library and Malhar contrib. You can have a look at that on the GitHub. There are a lot of different useful operators which are there as a part of it. Moreover, the same thing, because it's an inbuilt feature of Apex that fault tolerance and scalability is provided. The same application that we wrote without taking care of it, the fault tolerance and scalability is also there. And finally, the time to reduce time to production is definitely reduced. I mean, of course, one would definitely take this application through a proper QA cycle and so on, but well, at least the time for developers is definitely reduced. All right. So that's all I have, guys. Any questions?
So on the last point about recovery and all, right? So there is a question: how does Apex guarantee the two-phase commit between Kafka topic read by the consumer and HDFS?
All right. So the question is that how does Apex guarantees the reads done by Kafka consumer and writes done to the HDFS, right? So basically, Kafka operator and as well as HDFS operator has something called as some states which are saved with itself, where it knows that how much data is being read and how much data is returned down to the disk. Okay, using that, Kafka is going to read the data. In case of any failure, Kafka is going to read the data, which is only read the data which is not returned down to the disk. That's how it guarantees it.
One more question. The question is, I think Kafka Storm is a good bait. Please share your Kafka and Storm is a good bait. So maybe the question is how Apex is fares with that, because it's finally the same similar technologies that are being discussed here. Well,
so the question really is how Kafka and Storm is a good bet. Yeah. Now, I'm nobody to deny this particular point, but maybe this is I don't want to strike a conversation between between Apex and Storm, because they both have their own set of positives and both negatives. It's one's responsibility to evaluate what works best, but I know for sure that both works very well with Kafka. Okay? You'll be surprised to see how much Apex is capable of doing with Kafka when you see various different Malhar operators.
Yeah. So one thing is LinkedIn is just sharing the information that LinkedIn is using Kafka with 175 KB. Mm-hmm.
Yeah. So yeah, that's why we have chosen. It's a classic example of data ingestion that Kafka is there into place.
Yes.
a lot of big enterprises and companies are using it, and that's for a reason.
Is there a sample project in GitHub? Is this code available somewhere? Or?
There are a number of projects which are number of sample projects which are there in GitHub, but I think I'll be happy to open this particular code on GitHub, and we can share that particular GitHub link on meetup.com.
Yeah, what we can also do is update the PPT with this code link. The PPT link is already shared with all the participants. So given that, what we'll do is we'll update this information.
Okay. Yeah, sure, we can do that.
And the video will also be uploaded on YouTube. I have already shared the channel link for that. It should be up in the next half an hour.
And you can go to Malar GitHub, so you can see a number of different demo applications being written there, again as a part of open source, and that's like even more extensive examples than this.
So request to share the email ID. I think these details are available on the slides first page.
Yes, that is definitely the case, but you can actually you can visit apex.apache, apex.incubator.apache.org. We have the list of committers with list of contributors as a part of that page. We have a couple of community mailing lists also, especially the dev mailing list and users mailing list. So I think that's a great point where you can contact to anybody who is working on Apex.
Yeah.
All right, any other questions?
There is a question on can we know the release plan? So basically, Apex is already released, and you can give more info. Repeat the question.
So Apex Incubator, so the question was about Apex release plan. So basically we have two components in Apache Apex. So one is Malar and another is Apex Core, that is the real engine which does all these things. So Apex engine is released and it is currently at 3.3.0 version. Of course it is incubating, but it's at that version. And Malar is also released at 3.3.1 version there. Okay, so that's there, and the code has been tagged for this particular version. You can pick that up. At the same time, there are source stars which are available for these versions there. So all these details you can find on the Apex website there.
The question is, what is the difference between the open source community and the paid version? The difference between the two products.
Okay. So the question is difference between open source community edition and paid version, right? So first of all, Apex is a completely open source community. It is part of Apache, and as you can see that it has the complete engine in place, but it doesn't have a GUI and management console and so on into it. DataTorrent has created a community edition which is free to use, which uses the Apex internally. It provides some of the features related to managing a certain application, maybe killing or starting and stopping an application, doing a little bit with operators, configuring the operators and so on. There are paid versions of DataTorrent RTS also which are there that gives functionalities like basically support is major part of it. Other than that, we also do have some visualizations which are there. So what exactly is happening in an application is a big question that everyone has. All those questions, that's where the paid support comes in. Along with that, we do have in a paid version couple of other applications which are there, which one could use very easily to build an application on the fly. So it's like drag and drop kind of functionality that it provides, and at the same time some pre-built applications which one could directly use as well. So as a part of Data and RTS Community Edition, we also do have an ingestion application that one is free to use.
Yes. I think we have almost covered everything. Let me just go through quickly if there are any questions left.
Yeah, she's on the.
I don't want anyone to miss any question basically. So on the release plan, definitely we do have a few of the customers already in production. So this is a very production ready product, and it's already into the third major version. End of the year.
Right. So the psychology behind when Apex was started developing was Hadoop being it's a fantastic platform, but it is difficult to use and manage at times. So with Apex into picture, that was a primary goal that was kept in mind when Apex was developed. So that's one of the that's one of the things that why customers chose Apex and deployed that in the production.
Yeah, I think we have pretty much answered all the questions.
All right, guys. So lastly, I just want to go through the resources that we have. So as I said, we have a Apex website. You can go to the subscribe community link where you can find a dev users mailing list where you can subscribe to those mailing lists and you can get some exciting information about Apex project. You can go to the downloads page where you can download the current and previous released versions of Apex Core and Malar. We also do have Twitter, Facebook accounts. Please do follow. And finally, we are starting up with a startup program as well, where we are providing a free enterprise license for the startups, universities, and non-profit organizations. We do have a meetup, a live meetup that is coming up tomorrow. That's at 6 p.m. IST in ICC Towers, Pune. So that's mainly talking in details about ingestion of unbounded data. So if you are in Pune, do visit us. Thanks guys. Thanks a lot.
Just one more question. I think it's fine.
Thank you guys. Have a good night. Bye bye.